Alright, this should be our last video for just the notes in Unit 2-1, but as we get started, there we go. 6 and 7, a little bit more time consuming. In fact, 7 is going to take a little while, but let's get through 6 first. Observer of lighthouse. We have the lighthouse all the way up here at, well, that might be a little far. Lighthouse, which is 350 feet. There's my lighthouse, 350. Feet. Then we have 2 ships directly offshore, angle of depression 4 and 6.5 degrees. So we have 1 boat, and then we have 2 boats. And the closer boat is going to have that higher 6.5, and the farther one will have the smaller 4 degrees. How far apart are the ships? Okay, well, let's just figure out how far each one is from the lighthouse first, because if we can figure out this distance here and then this distance here, we can subtract the bigger from, and then big minus little, and get the distance we're looking for. So if we set up those trig functions, we have the angle 4 or 6.5, we have the opposite side, and we're looking for the adjacent side. So another tangent problem. Tangent of, well, let's just go with 6.5. In these types of problems, again, I've mentioned that in order to get x by itself, you can do 2 steps, or you can just understand that really those 2 steps are going to simply swap those two, the unknown and the number on the left side. So really that's going to look like x equals 350 tangent of 6.5. So x equals, let's see, do I have that one here? Yeah, I do have that. That would be 3,071.91 feet. We're going to do the same thing again with our new number, so tangent of 4. Same height of the lighthouse. We'll call this one y. We'll swap places. Y is equal to, 350 over tan 4. Y is actually a further distance, again, smaller angle, further away. That was 5,005 feet. .23. So the ships are D, I'm going to call that distance, is going to be y minus x. The farther distance minus the closer distance. And when we do that, we're just simply taking 5,000 minus the 3,000. We get 1,933.3 feet. Again, we'll box it in, but we'll make sure how far apart are the ships. That's the question being asked. And that is the answer I boxed in. On to number 7. Here we go. 7. We are just simply traveling across flat land. All we know is that we, at one point in time, measure our angle of elevation, and we're at 2.5 degrees to the peak of a mountain ahead of us. Then we drive 17 miles closer. We stop again, measure the angle of elevation to that same peak. We're at 9 degrees. The question is, approximate the height of the mountain. So let's draw this picture out. We have a mountain peak here, right there. We are going to know that our very, very first sighting is some distance x away. Well, let's label this. That first distance, that was 2.5. Then we were stopped again somewhere here, and we looked up at that same mountain peak. Let me fix that. And then our angle here was 9 degrees. So, see if I can do this a little bit of justice. So when we are looking at these two problems, all we know is that to the peak of this thing is some distance x. We're just going to label that x. Now, rather than calling the distance at our second stop some other value like y, or a, or b, or whatever, we're going to call that distance x take away 17. And the reason being, we know that the distance between our pit stops was 17 miles. So rather than calling this distance that's unknown another variable, we're going to call it x minus 17. You'll see why here in a minute. But keeping it with one variable is very, very helpful. Now when we go to draw our triangles, I'll redraw that. I think that's that color. Let's draw the two triangles out. So mountain, first observation is x, h, and 2.5 degrees. Next triangle, same height, a little bit closer, but I'm still going to have to draw a big picture. And that distance down below, that's that x minus 17, because that's this distance right here. Now we have two triangles. Let's write out their trig function relations. We have tangent equals h over x. Pretty simple. The other one here, tangent of 9 is h over x minus 17. So let's get x. No, wait. We don't want x. We want to know, it says approximate the height of the mountain. So let's get h by itself on both of these. So what that looks like is h is equal to x times tan 2.5, and h is x minus 17 times 2 tan of 9. Okay, well, we've already run our room here, so we're going to have to problem solve. Let's problem solve by saying, you know what? We don't need that. If you really need that information, go ahead and rewind the video. So what as I'm erasing here, what we're really getting to is we have h represented. We know we're trying to find h. And now we have two equations to represent it. So we know that h is equal to x times tangent 2.5, but h is also equal to x minus 17 times tangent of 9. What we can do is we can go back. I'm going to start up here now. We can go back and say, you know what? H is equal to these two equations down here, but h we also know is equal to h. That sounds kind of silly, but we're going to use that and say that, you know what? If we know that h is equal to itself, then we know that this equation is equal to this equation. And we're going to know that x tangent 2.5 has to be equal to x minus 17 times tan of 9. Because if h equals h, then those two equations equal, and we're going to move on. We're going to see that we now have one equation, one unknown. All we have is x's in our equation. So let's solve for x. Well, right now, X is on both sides of the equation. So we need to get x, all of the x terms on one side of the equation, and then we can get x by itself. So the first thing I'm going to do, I'm going to leave this alone. I'm going to distribute this x minus 17 right here. I'm going to distribute that. Well, I'm distributing the tangent of 9 degrees. But what I'm saying is I'm going to take, x times tangent of 9. So I'm taking tangent times the first term and then tangent times the second term. So x tangent of 9 minus 17 tangent of 9. Okay, so now we have the x term kind of broken out from this parenthesis, so that's good. But we still need to get both, we don't have an equals sign. We still need to get both the x terms on the same side of the equation. So let's do that by saying we're gonna add 17 tan 9 to both sides so that it becomes positive. See, if I add it to both sides, I'm also going to subtract x times tangent 2.5 from both sides. So if I add this to both sides, then it kind of goes from this side over to here. If I subtract this term from both sides, it goes away from this side and it comes over here. So really, I get 17 tan 9 equals x tan 9 minus x tan 2.5. Our next step is to factor the x out of that equation. So we say 17 tangent 9 equals x factored out tangent 9 and tangent. So I pulled the x from here and here. I pulled them out front. So it's really x times tan 9 minus tan of 2.5. Now that I've done that, I can divide both sides by this parentheses tan 9 minus tan 2.5. So now we have x equals 17 tan 9 all over tan 9 minus tan 2.5. We get a number. That x number is 23.47. But that's the x. That's right down here. That's x. We don't need to know x for our final answer. What we need to know for our final answer, we have to erase even more. I'm going to remove these pictures and find some room here. Final answer. Here we go. Final answer is we have a triangle whose x is 23.47. This is h and this is 2.5. So we know that tan of 2.5 equals h over 23.47. So we take both sides times 23.47, and the height of this thing is 23.47 times tangent 2.5. You get 1.02 miles. There you go. Very lengthy problem. I'm sorry that took the entire 15 minutes that I have on these videos, but I'm sure you could fast forward or rewind quick and hit the chunks you need to know. But if you understand that process, you can solve any of these problems out there. This one was just more involved because we had to represent two different lengths using one variable. So there you have it. Thank you for listening. We'll move on to practice problems in our next sets of videos.